Namaste, I am Om Prakash Chaudhary, Assistant Professor, Faculty of Agriculture and Veterinary Science, Jyoti Vidyapeeth Women's University, Jaipur. Today I will discuss about principles and methods of preservations. So, food preservation can be defined as the science which deals with the methods of prevention of decay or spoilage of food, and thus allowing it to be stored to in a fit conditions for future use. So firstly I describe the principles of food preservations. So first is the prevention or decay of microbial decompositions. So prevention or delay of microbial decompositions through keeping out microorganisms, for example asepsis, and by removal of microorganisms by filtrations, and by hindering the growth and activity of microorganisms, for example by low temperature, drying, anaerobic conditions, chemicals and antibiotics, and by killing the microorganism through heat or radiations. Second method is prevention or delay of cell decomposition of the food. So the destruction or inactivations of enzymes increase the shelf life of foods through, like for example blanching is the process for self reduce self decomposition of food, and by preventions or delay of chemical reactions, for example preventions of oxidations by means and an oxidant. And third method is prevention of damage by insects, animals, mechanical causes. So the methods of food preservation is, first one is preventions or delay of microbial decompositions. So first is by keeping out microorganisms and asepsis. So asepsis means preventing the entry of microorganisms and maintaining the general cleanliness while picking, grading, packing, and transport of fruits and vegetables, and washing or whipping the fruits and vegetables before processing process. And second is by removal of microorganisms, for example by filtration method. So in this method, soft drinks, fruit juice, and wines are clarified by setting or by using ordinary filters, and then passed through special filter which are capable of retaining yeast and bacteria. And it is not used in India. And third is by entering the growth and activity of microorganisms. In this method, the preventions by low temperature and microbial growth and enzymes reactions are reduced in foods stored at low temperature. And lower the temperatures, the greater the degradations. And low temperature can be produced by cellar storage about 15 degrees Celsius, and refrigeration or chilling temperature 0 to 5 degrees Celsius, and freezing is minus 18 to minus 14 degrees Celsius. And through cellar storage, the temperature in cellars where the surplus food is stored in many villages is usually not much below that of outside air and seldom lower than 15 degrees Celsius. And it is not low enough to prevent the actions of many spoilage organisms or of plant enzymes. And decomposition is, however, slowed down considerably. And root crops, potatoes, onions, apples, and similar foods can be stored for limited periods during the winter months. Through refrigerations or chilling, the chilling temperatures are obtained and maintained by the means of ice or mechanical refrigerations. And fruits and vegetables and their product can be preserved for a few days to many weeks when kept at these temperatures. The best storage temperature for many foods is slightly above 0 degrees Celsius, but it varies with the product and the fairly specific to it. So freezing, next method is freezing. So freezing method is most harmless method of food preservations, and microbial growth is inhibited and the rate of chemical reaction is slowed down at lower temperature. And foods can be quick frozen and about 19 minutes or less by placing them in contact with the coil through which the refrigerant flows, and blast freezing in which cold air is blown across the food and dipping in liquid nitrogen. And most perishable foods can be preserved for several months. The temperature is brought down quickly and the food kept with these temperatures. This method is particularly useful in case of juice whose flavor is adversely affected by heating. And properly frozen juice retain its freshness, color, and aroma for a long time period. And juice can be kept in good conditions for a long time in frozen from -12 to -17 degrees Celsius by excluding air. So next method of preservation is preservation by chemicals. So a preservative is any substance which is capable to inhibit and retarding or arresting the process of fermentations, acidifications, or other decomposition of food, but it does not include common salt, saltpeter, alcohol, species, spices, essential oils, or any other substance added to the food by the process of curing. The inhibitory action of preventive preservatives is due to their interference with the mechanism of cell divisions and permeability of cell membrane and activity of enzymes. And chemically preserved squashes and crushes can be kept for a fairly long time even after opening the seal of the bottle. And a number of chemicals such as hydrogen peroxide, formaldehyde, acetic acid, salicylic acid, etc., which were used as a preservatives some years ago and have now been banned in many countries. In recent years, except potassium metabisulfite and sodium benzoate and sorbic acid and tylosines extracts are being tried. So the two method important chemical preservatives permitted in country are sulfur dioxide including sulfates and benzoic acids including benzoates. So first is sulfur dioxide. So it is generally used in the form of its salt such as sulfite, bisulfite and metabisulfite. And potassium metabisulfite commonly used as a stable source of sulfur dioxide. According to Indian Food Product Order, the maximum amount of sulfur dioxide allowed in food use is 700 ppm in each squash, crash and cordial, 350 ppm, and in RTS and nectar 100 ppm. So the advantage of using sulfur dioxide is it is widely used throughout the world and the preservations of juice, pulp, nectar, squash, crash, cordial and other products. and it has good preserving actions against bacteria and molds and inhibit enzymes. And in addition, it acts as an antioxidant and blanching agent, and these properties helps in the retention of ascorbic acids, carotene, and other oxidizable compounds. And potassium metabisulfide, it also retards the development of non-enzymatic browning and discolorations after killing the enzyme of the product. And it is fairly stable in natural or alkaline media but decomposed by weak acids. When added the fruit juice or squash, it reacts with the acid in the juice, forming the potassium salt and sulfur dioxide, which is liberated and forms sulfurous acids with the water or juice. And it has a better preserving actions than sodium benzoate against the bacteria fermentations. And being in a gas, it helps in preserving the sulfur surface layer of juice also. And being highly soluble in juice and squeezes, it ensures better mixing and hence their preservations. And any excess of sulfur dioxide present can be removed either by heating the juice to about 71 degrees Celsius or by passing air through it or by subjecting to the juice vacuum. And the many major limitations of sulfur dioxide is and it cannot be used in naturally colored juice like falsa, jamun, pomegranate, strawberry, colored grapes, plume, etc. on accounting of its blanching actions. So sulfur dioxide only used for non-colored fruits. So it cannot be used for and it cannot be used for juice which are to be packed in tin containers because it not only coats the tin cause pinholes but also forms hydrogen sulfide which has a disagreeable smell and reacts with the iron of the tin containers of to form a black compound, and both of which are highly undesirables. And sulfur dioxide gives a salty slight taste and odor to freshly prepared beverage, but these are not serious defects of if the beverage is diluted before drinking. So second chemical is benzoic acids. So benzoic acid only partially soluble in water, hence its salt sodium benzoate is used. So sodium benzoate is thus nearly 170 times is soluble in H benzoic acids. And pure sodium benzoate is tasteless and odorless. The antibacterial action of benzoic acid is increased in the presence of carbon dioxide and acids. For examples, Bacillus subtilis cannot survive in benzoic acid solutions in the presence of carbon dioxide. Benzoic acid is more effective against yeast than against mold, and it does not stop lactic acids. According to APO, it is permitted level in RTS and nectar is 100 ppm, and in squash, grass and cordial is 600 ppm. It is therefore mostly used in colored products of tomato, falsa, jamun, pomegranate, plum, watermelon, strawberry, colored grapes, etc. So next method of preservation is by drying. So microorganisms need moisture to grow, so when the concentration of water in foods is brought down below a certain level, they are unable to grow. And moisture can be removed by the application of heat, as in sun dry or mechanical drying. and this is more rapid process as artificial heat under controlled condition of temperature, humidity and airflow. It provided and fruits and vegetables, for examples green peach, cauliflower, mango, etc., are dried to such an extent that microorganisms present in them fail to survive.